I think that is a very important thing that you touched on. That um, space of time between grade 7 and grade 9, where we kind of throw away the childish, I'm using air quotes here, the childish ways that we use to get children engaged in math. What do you think informs that decision to take away the fun from math?
Such a good question as well. I think there's a notion that, from my perspective as a teacher, and I don't know if every teacher will agree with me, but definitely my perspective is that I think we assume because these teenagers have they almost are adults, right? Some of the grade 10s are taller than probably both you and I, right? They're
Yeah,
big kids. So we assume they have an adult brain. We assume they can make these connections in their head already when they can't. Like I said, if we're talking about X, this is a variable. It's a very unknown number. And I'm sure me just talking about algebra is giving our listeners like a little
yeah,
bit of math anxiety. But the second we say, hey, this is what this is, it's a square or a rectangle. And it means this many numbers. Again, you can bridge that gap. So I feel like we forget that our teenagers are still kids. And by bringing the math manipulatives in, by bringing in these tangible creative parts, even in the arts, we are going to get that buy-in, but it also feels fun and playful.
hmm,
And again, it's going to reduce that stress that I think a lot of people have around math.
right. So I do still want to talk about this, and then maybe this is because I have a kid in that age range. But how do you? Because I know that for kids of that age, they, as much as we are trying to take away the childish stuff away from them, they are also walking away from that childish um from those elements. So how do you? I guess what is the middle ground? How do you help that child access that creative side to be able to embrace math while honoring the new season that they're going into, that season of adulthood? What are some creative strategies that you use?
Again, amazing question. So part of the way I kind of frame everything is applying it to real life situations. I think if we can apply it to a real life situation, then they understand the why behind this. So one of my favorite examples is surface area. So surface area is a it can be a very complex concept. So we're
Just feel
talking
free to
about,
use a physical,
yeah, I was just gonna say, I'm
feel free
looking
to use a
around.
demonstrate
I'll
to
grab my
demonstrate if you
I'll
want.
grab my tissue box here. I'll use that as an example. And then
Okay.
remind me if you need me to send you the video. I've got the video of the kids that made the actual stuff that I'm going to talk
Oh,
about.
amazing.
So I
Amazing.
can totally send that your way. But so let's say we're looking at like the 3D shape of this. It's a tissue box for our listeners, right? And we're talking about surface area. So we are looking at what is the area of the top, the bottom, the sides, the parts, um, I guess the other sides of the box, right? So it's a three-dimensional shape and they have to figure out the surface area. In my classroom, what I did is I gave them, they had to bring recyclables. That's why I decided to use the tissue box. And they had to wrap it in wrapping paper.
Okay.
And so that challenges them to really measure out the surface area of each side because they need the right amount of wrapping paper to wrap their object. And the challenge was they only had an extra, I think I gave them, if my students are listening, they're going to be like, no, you didn't, Miss Mall. But I think it was an extra 10 centimeters square for just any overlap. But they had to calculate all the sides, come to me. I cut the paper. They went back to their desks and actually wrapped up their boxes. And then, it becomes artsy because we get to use nice gift wrap paper. We get to use the crafting side that my students have. It's a real life problem because if you are painting the walls of your home, you need to know how much paint you're going to need. You need to calculate how
Yeah.
much that's going to cost. It also, ties into um, them even having that concept of, oh, 10 centimeters squared is actually not that huge. So now I really need to think about my calculations, or maybe I thought I was calculating the area of this side correctly, but I wasn't. And it gets them really thinking about using these materials in a real world way, but also helping in their learning.
That's an amazing example. And I'm just here thinking, well, I wish I had a teacher like you when I was growing up. My life would have been better.
Oh, I appreciate that so much. I really do.
But I think it's very interesting when we find these levers that will help children access complicated topics. So shout out to you for doing amazing work.
Thank you so much.